Thank you for the introduction, and thank you everyone. Great presentations and really honored to participate in this forum. So we're at EVŌQ Nano, a breakthrough nanotechnology company, and we create materials that make existing technologies work better. Our products impact multiple verticals in various ways, ranging from killing microbes in healthcare to reducing odors in textiles. Today, we are focusing on improving battery charging and duration. In the battery marketplace, we help rechargeable energy systems. Next slide, please. We help rechargeable energy systems charge faster, hold more charge, last longer, and operate more safely using our material, which I'll discuss more momentarily. But let's start first, next slide, with some of the issues in the battery marketplace. So there's significant future demand, and there is a need for batteries to recharge faster and for them to be more efficient. Let's start with demand with the next slide. Many of you are well aware of the fact that the demand is large and growing. In fact, estimates assume over 300 million home and public charging stations required by 2040. And if you look across the renewable types of batteries, both lead acid, next slide please, both lead acid and lithium and other forms, all have large anticipated growth in demand. Next slide. Before we get into the other two issues, let me introduce the product we're discussing. So EVŌQ Nano uses our patented laser process to produce a gold allotrope. Allotrope just means another form, kind of like diamonds, a different form of graphite, but same underlying chemistry. And from that gold, we create this EVQGA, which is a name for a gold-derived nanoparticle engineered very specifically for different uses, in this case for energy storage industry, and with particular size and form. The nanoparticles are extremely small, they're spherical in shape, they're consistently distributed in solution, such as an electrolyte solution, and they're non-ionic so that they will not aggregate and fall out of solution. These properties uniquely improve battery performance and address some serious challenges. So next slide, let's talk a bit about one of the big challenges that is well known in the rechargeable battery space. And that is that as you build faster charging batteries with greater energy storage, that's the challenge. There's a concern of dendrites. Dendrites are large crystals or large electroactive species. And you might consider these the cancer of rechargeable batteries. The big, large crystals cause problems. The small ones are the things that are good. Recharging batteries rapidly forms these big crystals, these big dendrites. They slow the charging process, they limit the capacity, they shorten battery life, and can result in some cases in batteries shorting out, and in some extremely rare cases, combustion. We put here a quote from one of the leading luminaries who wrote in the US National Academy of Science recent article that building a fast charging battery that can suppress dendrites is a holy grail problem. So dendrites are the cancer, and suppressing dendrites is the holy grail that we're pursuing, which then leads us into talking about what happens, next slide please, when we incorporate our product. So on the left, you see a picture where there's a normal one without our product, and you see some of these large crystals in that blue circle. That one's greater than 1,000 nanometers, very large. On the right, you see a picture where our material has been included, and you have crystals that are no more than a quarter the size of that large one. Next slide. The result of having fewer of these large bad crystals and more of these smaller crystals or electroactive species is a faster charging, longer lasting, safer, and more durable battery. Next slide. The formation of these smaller crystals, electroactive species, we've got a lot of tests and data we can share, just a couple here. On the left, you see the two flat lines are control. The two rising lines are the ones where our product's been added. And you see that as the battery was charged more and more, you had an increase in power, over 100% increase in power or amps. And on the right, you see that the charging speed also increased by over 80% faster, which would result in about a 20 to 40% decrease in charge time. So some real exciting results that we've seen in a number of formats. Next slide. The product that we have is different than a lot of nanomaterials, which we could describe more at a later date, but at this point we'll say that there's 22 granted and 23 additional patents have been filed. And of those patents, 9 issued, 10 filed pending are specifically relevant to the battery marketplace. In addition, our team is working with world-class university researchers and have access to National Science Foundation's materials research labs that include access to very, very hard to access STEM imaging and EDS technology. We've received recognition across multiple verticals in healthcare and textiles, and specifically to battery. Based on our performance and results, we were asked to speak at the Lead Acid Battery Conference earlier this year. What's next for us? Next slide. We are seeking for partners to work with us. We're seeking to establish up to 10 pilot programs by the end of next month. Partners who participate would receive not just material, but also access to videos, customized support. That would lead to actually testing their own batteries, and then RFPs in November, long-term partnerships and so forth. So next slide.
30-second warning.
Thank you. This is our team. We've got very strong scientists and scientific background, as well as industry-leading people on the business development and on the grant application side. Next slide. So we're super excited to work with you and anyone else that you're aware of that's interested in accelerating the future of energy storage systems for rechargeable batteries, and welcome any questions and look forward to any collaborations.
Thank you, Brian. First question from Dana Jensen.
Yeah, sure. It's interesting that you found maybe a solution to the dendrite problem. Obviously, that is a holy grail sort of issue. It's also why a lot of people are throwing their weight behind solid electrolyte applications, right? And if they can overcome the manufacturability problems with the ceramics in particular in a solid electrolyte, maybe that's the solution to dendrites, or that's what they would claim. Could you speak to whether or not your materials would be applicable in a solid electrolyte battery, or is this pretty much, it seems like, strictly in the kind of traditional liquid electrolyte role?
It does apply. They would apply to the oxide paste as well in the solid world.
Okay, thank you.
You want to ask a question?
Sure, yeah. So I know you have intellectual property filed in 16 foreign countries. Does your product or marketing or IP include any, which Asian countries do you have presence in IP and marketing or not?
So about half are abroad, and I would love to share that with you. Why don't we do an offline email? That would take longer to describe than I think our time permits, but I'd be happy to share. We have applied for patents across Europe and Asia, and have patents issued across both.
Perfect. Great product presentation. Thank you.
Thank you very much. But please contact me. I'd be happy to discuss further.
Yep. Oh, well, thank you.
Go ahead, Bob.
Hey, Brian. Nice to meet you. Good presentation. So I'm interested in any ongoing commercial proof of concepts you might be entertaining or working with now. I'm with Mitsubishi Chemical. We're very involved in this space. So the challenge, of course, in any kind of material evolution is getting it into production. So we also found that at Panasonic as well. So I'd really like to hear about your approaching the market players and how you fit in the ecosystem.
So first of all, outside of batteries, we've got active partnerships, and we have actually commercial sales across textiles, oral care. We're in early trials in healthcare setting, but specific to batteries, we have active tests going on with 2 major battery manufacturers, and in discussions with others as well. And we'd love to add more. What we found is that universally across multiple tests, we're seeing improvements in performance, but it definitely differs by the battery company. And so we think the most useful thing is to actually partner with a company and have them tested in their own environment. What's nice about our product is that it's non-intrusive. You add it to the electrolyte and it goes in with the electrolyte or the paste. So you can incorporate it into your battery without having to alter your R&D or manufacturing process.
Thank you.